BusinessNet Explorer, product news podcast channel. This is B&E Product News, supporting specifiers and buyers. This podcast is sponsored by the B&E Product News podcast library. Well, hi, this is Mick de Leyburn and welcome to a special edition of the B&E Brand Leader interview podcast for our Building World Product News playlist. In this edition, we discuss how to select and size a commercial humidifier to ensure an indoor area does not drop below a certain humidity. Dave Marshall-George, UK Sales Director at Humidity Control Specialist Condair, joins us on the phone to help us to understand a bit more about humidification system design. Well, hi, Dave.
Hi, Mick.
So, Dave, I think most of us are quite familiar with dehumidifiers, as they're often used at home for things like drying laundry. But can you explain a bit about what a commercial humidifier is and why you might use one?
Sure, and you're right. People can get a bit confused between humidifiers and dehumidifiers. So, whereas a dehumidifier takes moisture out of the air, a humidifier does the opposite. It puts moisture into the air. And they're typically used for one of three reasons. Firstly, to keep an area's humidity above a certain level to stop something from drying out and losing moisture. Now, this tends to be in a manufacturing application where materials like food or paper will degrade or suffer in some way if they lose moisture. So, humidifiers are used to raise the air's humidity to a level of equilibrium and stop materials from drying. Secondly, a steady, stable environment is often needed to preserve things like valuable paintings or wooden furniture. Museums and art galleries will use humidifiers to keep the indoor air at a very specific condition, as changes in humidity over time can gradually damage exhibits. And this is due to the tiny shrinkage and expansion that can happen if the air humidity fluctuates too much. And lastly, and really importantly, buildings will use humidifiers to protect people's health. Our immune system does a fabulous job at protecting us from airborne viruses most of the time, but when we breathe dry air, the mucus inside our nose and throat dries out, and this reduces our ability to fight off airborne infections like colds and flu. So companies will humidify places like offices to protect their staff and reduce their absenteeism.
Okay, so a lot of applications there, and I'm guessing that lots of things to consider when selecting the right humidifier.
Yeah, absolutely.
So where does someone who needs to manage a building's humidity start? What's the first thing to think about?
Well, one of the first decisions that needs to be made is whether you're going to introduce humidity directly to a room's atmosphere or put it into a building's air handling unit, often referred to as an AHU. Now, if a building has an AHU, the simplest option can be to fit the humidifier there. But many buildings and factories don't have this. They don't have an AHU. So humidifiers can be installed directly in a room, or at least close to the area in question, with a duct feeding the humid air to where it's needed.
So are air handling units not able to control humidity to start with?
No, not always. A lot of AHUs are fitted with a space for a humidifier should one be needed, so they can be retrofitted if the need arises. However, sometimes even with an AHU in a building, there can be times when it's better to fit the humidifier locally. For instance, if humidity control is only needed in one area of a large building, it can be cheaper to use a single small direct room humidifier.
Okay, so once we've decided on putting it in room or alongside an AHU, what next?
Well, next is deciding on the technology. What type of humidifier is best for the project? Now, there are three ways to get water into the air. We can boil it, let it mix with the air, we can spray it, or we can evaporate it. And the different types of humidifiers all use one of these three methods. Steam humidifiers boil water, spray and ultrasonic humidifiers create an aerosol, and evaporative humidifiers evaporate water from a wetted surface. Each has its benefits, and matching these to a specific project's needs is a skill that can take years of experience to master for our humidifier sales engineers.
So not something we could comprehensively cover in a short podcast.
No, not really, Mick, but we can give some general guidelines. For instance, steam humidifiers are the most commonly used. They have a really wide range of outputs, from a few kilos per hour to around 80. And they're straightforward to install and can be used on AHUs with a steam pipe put inside the duct, or directly into a room with a fan unit blowing the steam into the space. They come in electric versions, gas-fired, or even ones that use a building's existing boiler steam. Next, there are spray humidifiers. These are ideal for large areas when humidifying directly into a room. They can give up to 750 kilos per hour from a single system, but can also be used inside an AHU with lower outputs. And they do offer an added benefit of cooling alongside humidification. In fact, any cold water humidifier will do this for you. Another type are ultrasonic humidifiers, and these tend to have smaller outputs, so are useful for small areas like a humidor or a display cabinet. And lastly, evaporative humidification, where moisture is evaporated directly from a wetted surface. And these are a great option for AHUs if space allows. Any cold water humidifier will typically take up a bit more space inside the duct than a steam humidifier's steam pipe. So for AHUs, the duct section length can be a deciding factor in the production selection. Oh, and commercial mobile humidifiers tend to use evaporative technology too. They can typically deliver a few kilos of humidity per hour and are useful for places like art galleries or small offices.
Okay, Dave, you mentioned cooling there with cold water humidifiers?
Yeah.
Okay, so how does that work? Can humidifiers be an alternative to aircon?
Well, not really a replacement for aircon, but they can have a place. Whenever water is evaporated, an evaporative cooling effect happens. Now, if this is useful, like in a hot factory, then it's a really nice bonus, and you can help lower cooling costs. But often we're humidifying places in the winter, and this is because indoor air is much drier then, and this isn't the season we normally need more cooling. So in fact, cooling from a cold water humidifier will often need to be counteracted rather than enjoyed. So evaporative or spray humidifiers operating in the winter inside an AHU will need some form of heating before the humidifier. Now, this makes the air warm enough to be able to accept moisture from the humidifier, and also ensures it's at the correct supply temperature after the evaporative cooling effect.
Okay, so how about energy? With the need for buildings to be more sustainable and the high cost of energy, how does energy consumption influence humidifier system design?
Yeah, good question. And although energy does influence humidifier selection, the answer isn't necessarily straightforward. You might think with a steam humidifier constantly boiling water, they're going to use more energy than an evaporative humidifier, which is basically just pumping water onto a wetted surface. But in both cases, the energy needed across both cold water and steam systems is often the same. And this is due to the need for the preheating. As I just mentioned, the cold water humidifier isn't directly using the same energy as a steam humidifier, but the energy used is being shifted to a heater ahead of the humidifier, often a gas-fired heater. But if you've got waste heat available, and this can be used for preheating, then this can really make for a low energy humidifier system. Nowadays, though, people are more concerned with whether energy is from a renewable source. As you said, sustainability is key. For example, electric steam humidifiers operating on renewable electric energy are a more sustainable option than a cold water humidifier used with gas-fired preheating. As buildings move towards net zero, this is becoming a really important factor for selection.
Okay, very interesting that. So what's next? Beyond energy, size of output and choosing steam or cold water systems, what's next on our selection checklist?
Well, I would say our last major deciding factor is control accuracy. A project that needs very precise humidity control will be limited to units that can fully control their output from 0 to 100%. This means they can deliver just the right amount of moisture when needed. Resistive steam humidifiers are often the close controlled humidifier of choice, but ultrasonics might sometimes be used for very small areas. There's also a type of induct humidifier, a hybrid system that offers close control by combining evaporative and spray systems. Now, all of these can control to around plus or minus 1 to 2% relative humidity. Beyond that, if a project needs plus or minus 5% control, then electrode boiler steam or spray systems become an option. Then for an even wider plus or minus 10% RH, we can consider evaporative or gas-fired steam units.
Right, and once you've figured out what type of humidifier is right, the right fit for a project, I'm guessing the next step is sizing. How do we know what size humidifier to install?
Yeah, that's right. And to figure that out, we need to perform a psychometric calculation. And we do that using a psychometric chart. A psychometric chart shows the relationship between air temperature, relative humidity, and air's physical moisture content. These three characteristics of air are intimately linked together, and changes to one impact the other two. So by plotting our building's starting air condition and our required end condition on a psychometric chart, we can calculate how much moisture we need to add to 1 kilo of dry air to get it from starting point A to its end point B. And once we know this, we just need to multiply this amount of water by the overall air volume flowing through a room or a duct. And then we have our humidifier size.
You make that sound easy, Dave.
It is once you've done it 100 times, but yeah, for the uninitiated it can be a complicated process. But we do have webinars explaining this calculation on our website, condair.co.uk, along with downloadable copies of the psychometric chart itself. And we're always happy to perform these calculations for anybody considering a humidification project.
And for anyone wanting this, what was it you said was needed? The air condition information?
Yeah, for an accurate sizing, we need the temperature and humidity of the air at its starting condition. This is when it holds the least amount of water and is typically the coldest possible outdoor day in the winter, which for the UK mostly tends to be minus 5 degrees C at 100% saturated. We then need the desired air condition inside, so whatever the air condition is that you need to maintain, for instance 23 degrees C, 55%. Then, if there are any other sources of moisture in the area, then knowing this will help us give a more precise load calculation. And this should include people too, as they can be a source of water that needs to be considered. And lastly, we need to work out how much air we're dealing with. So the size of the area in question is important, as is any information on the air handling unit's operating parameters.
What if someone is unsure about any of these things?
Well, that's not unusual, and like we say to many people, I suggest they just talk to us. We're always happy to visit sites and to give free expert advice, so please do just get in touch and we can walk through the whole process.
Well, there you have it. How to select and size a commercial humidifier. Yes, rule number 1, talk to the experts. Thank you for sharing your industry expertise again with us today, Dave.
You're welcome. Thanks, Mick.
You can find out more about humidification specialist Condair and the products and services they provide by visiting the company's website at www.condair.co.uk. And please take a moment when you can to check out the other B&E Brand Leader interview podcasts in this series that feature Condair and provide unmissable insights from Dave Marshall-George on subjects such as how to control static by controlling humidity, how to select and size a dehumidifier, exploring the evaporative cooling opportunity for HVAC system specifiers. Understanding the relationship between health and humidity is key to optimising air quality. Optimising humidity control to increase profits for food and drink manufacturers. And how dehumidifiers can improve safety and efficiency in cold stores and freezers. You can find these on the Condair website and the BusinessNet Explorer Brand Leader podcast playlist. Well, thank you for joining us for this latest edition of the B&E Product News podcast. And please, stay safe. Follow us on Twitter at B&E Product News to keep updated on our latest product news podcast releases, and visit us at businessnetexplorer.com to find more product news and information for specifiers and buyers in the construction and building services and associated manufacturing and energy sectors. BusinessNet Explorer podcasts are now available via the Apple Podcasts app, iTunes and on Spotify. You can subscribe to access our existing content and, of course, to receive every new podcast that we publish in audio format.